In this video, I'll be going over how to create an assembly for a siding track. I won't be going over how to um, do super elevation in this video, or nor will I be designing the rail, the ballast, and the tie. This is just going to be a basic assembly to generate surfaces and calculate quantities eventually once we create a corridor. So to get started, you're going to need a typical section for what you want to do. This will be helpful when we want to um, grab dimensions and things like that. So for this example, I'm going to be designing a siding track adjacent to an existing main line. So I'm going to need to know roughly like the how close to the track I can build subballast, roughly how thick the subballast layer is, and how deep the ditch needs to be if there needs to be a ditch, the shoulder of subballast and things like that. So once you've figured that out, and you don't have to make it this detailed, you just need some rough dimensions and things like that. So to get started, we are going to create an assembly here in the home tab, assembly, create assembly. I like to give the name a little bit more of a description, because if for a more complicated or longer um, corridor, you're going to have several different assemblies, so you're going to need to know which assembly to apply for which range. So for this one, we can call it siding ditch. This is going to be a basic ditch section. We can use a railway assembly type, and I'm going to just use the standard settings for the rest of it. Hit OK, and then come down here. And this is our basic assembly. And you can select it, hit Tool Palette here, and it'll bring you up all your subassembly tabs. And yeah, so the basic bread and butter of your assembly building from Civil 3D is the generic tab. This kind of with these tools here, you can pretty much model anything you want. Um, if it's not listed here, you're probably gonna have to create a custom subassembly with the subassembly composer. But for this tutorial, I'm just gonna be using what Civil 3D provides you, so that everybody could follow along. So just to give you some background, before you create your assembly, you're going to need to know or have a plan on how to model this. In my case, what I'm going to be doing is I'm going to be starting my profile so my profile is at the top of rail elevation, so I'm going to need to model the subballast here. And you can see that the subballast starts at this point here. That's at my excavation limit. And then it builds out this way with the 0% on top and 3% slope at the bottom. And then I'm going to have a 3-foot deep ditch with 3-foot deep ditch and 4-foot wide, and it goes back up at a 2-to-1 slope. So basically, I'm going to need to get from this point here to this point here to start my subballast. So we can use a simple distance command, and if you have this all drawn correctly, you can measure things right off your section. So if we measure from there to here, you can see now that we need to go down 0.706 meters, and then go to the left 2.022 meters. So we can go back here, And then to go down, you can use link vertical. So we can click that, go back here, just read off the dimension 0.706. Okay, we'll write points negative since we're going down, negative 0.706 meters. The point code and link code will remain as is because we're actually going to omit this later, so we don't care about those things right now. Hit enter, and we can just draw it. And you can see this purple or pink line that we just drew that takes us down 0.706. Next thing, we want to move it to the left, 2.022. So we'll go back and we can use offset, link offset and slope. So to the left will be negative again, so 2.022. Slope we want to be 0 because we've already moved down by the required amount. These two once again will remain as is because we will eventually omit this code. And actually just to simplify this, I'm going to add it to here. And then what I'll do is I'll move this. So whenever you're moving assemblies, you want to use these commands here, copy, move, and mirror. So I will move this and move it there. Now we've gone from our top of rail point, we moved over 2.022, and we've gone down 0.706. So we're at this point now. Now we can do our subballast, our top of subballast. So we can use, once again, these link codes, but when I'm doing subballast, I like to use the shoulders, and we can do shoulder extend all. And for here, shoulder width, we can actually measure this, but for now I will keep it at 2.4. Shoulder slope, I believe this is the top of slope, so I'll put that at 0. We are doing a 2-to-1 slope, and the subballast slope, so that's the bottom, we'll do -3. And for these ones, so we don't have pavement depth, we don't have a base depth, but I'm gonna use 0.305 for the sub base. And we'll go here and we'll click it. Oh, I selected the wrong side, so should have done this. I want it to go to the right, and we'll do that. So next up, we will do just a quick measurement here. So it should be 5.368 meters. So we can, once you've created, you can always edit these things. So it was 5.368. Like that. And yeah, so if you ever want to change these things, you can always select them and change it from there. And you'll notice that the top is flat, the bottom is 3%, and like if you want to go to 5%, you just go like that. It's pretty simple. Now, these two links have served their purpose. We actually don't care about them, so we can omit them like this. So now we have this floating assembly here. If we ever want to go back and say, oh, I want to reduce my excavation depth, so if you want to get it back, you'll have to go to Disassembly Properties, Construction, and you can see all the assemblies here. So you can go ahead and edit them. You can, increase or reduce this number, and you can go to vertical, and you can change everything through this. Next up, so we want to model our ditch. So the ditch, what we're gonna do for the ditch is we're gonna create another profile for the ditch. So we want to reference that profile. For this task, we will go back and we'll go back to our trusty, not daylight, generic slopes, generic links, sorry, and we will use offset and elevation, I think. No, slope to elevation. Yeah, because then we can use a 2-to-1 slope and we will link to the ditch. So slope to elevation. Now the slope for 2-to-1 is 50%. So it's 1 divided by 2. Target elevation, we'll put 0 for now, but we'll actually reference a profile when we go to design a corridor. Point code and link code, we'll actually keep it as is, but maybe if we want to create a label, we can actually make this ditch. Yeah, well, we can just go ahead and do that. Let's call this ditch. We don't want to omit it, so we'll do that. So since our ditch, we want it to go down, we can actually change this to away from, no, towards crown. There we go. Okay, and then next up we can do offset, no, offset and slope. So this is the bottom of the ditch. We are with ditch width is 1.219, 0%. We'll also call this one ditch. So we're gonna get 2 ditch lines here, and we'll do that. So this point is ditch, this point is ditch. This becomes more important when we create our corridor and we can apply feature lines and things like that. Now the last step, we want our daylight again. So for this one, you can use a daylight. There's many different types, but I like to keep it simple and just use, there's a slope to surface here, link slope to surface. And we can use this, so 50%. So we can specify whether it's cut or fill. For this one, yeah, I can just leave it as is. And we'll give it a point code. We'll call it daylight. And we will put it right here. And there you have it. This is a basic subassembly. Now, there's a couple more things that are kind of like best practices and just helps with the modeling part once you get into the corridor and applying this assembly. So we want to give some of these things names. So for this one, I'm going to call this Subballast. This is going to be our link to ditch. And we can call this one ditch bottom. And this one, we'll call it daylight. So we got that. Last step here, we actually want a stripping line. So when the contractor goes out here, they'll strip away this topsoil. There is a neat little subassembly that will do that for you. Just have to remember, I think it's in, here we go, daylight. So it's a bit strange, but the stripping stop topsoil is what we're trying to do, but this assembly works a little bit different than what I'm used to. So I'm going to use this stripping pavement one, which has worked well for me. The stripping depth, we will strip away a foot or 0.305. Extent to existing ground, yeah, we can leave it as that. For the slopes, I want to do a vertical cut. So I'll just do 0. We'll put one on this end and we'll put one on this end. So what this will do is this will just link this point. It'll strip down to the surface and it'll run along the surface and it'll end here. That is how you do a basic subassembly for a rail track. And in my next video, I will show you how to apply this subassembly to create a basic corridor. Thanks for watching. Bye.